Hi guys, so if you remember the other day we started factoring by GCF, and I had mentioned that there are many different kinds of factoring. So today we're going to look at a different kind of factoring, which is factoring into two binomials. And remember that factoring is the reverse, going backwards, of multiplication. So we know that when we multiply two binomials, like in the top you see x plus 3 times x plus 5, we know that we use what method to multiply those? We use FOIL as our little acronym that we multiply 4 times. First times first is x squared, outsides 5x, insides 3x, and lasts give us 15. And when you combine these two middle terms, we call them the middle terms, we end up with x squared plus 8x plus 15. Well, if you look closely, the middle term 8x is the sum of 3 plus 5. And if you look at the last term, 15, that's the product multiplying 3 times 5. So the two numbers that are inside of the parentheses end up getting added to make the answer in the middle and multiplied to make the constant answer at the end. So you're always going to see, when you multiply using FOIL, you're always going to see this formula result, which is a number, or just x squared. So like a, in the formula in the box here, ax squared. In this case, a is 1. There's an invisible 1 in front of x squared, plus a number times x, which we call plus bx, plus a number at the end, which we call a constant, which is c. So whenever you multiply using FOIL, again, you're going to end up with your answer looking like this formula or format: x squared, or invisible 1, x squared, or ax squared, plus bx plus c. Okay, so right now all of our answers are going to have an invisible 1 in the place of a. So that's why I have in parentheses where a equals 1. They get harder when a does not equal 1, when it's a number other than 1. So we're going to look at those tomorrow or the next day. All right, so when we look at examples like example 1, and it says factor g squared plus 7g plus 10, the first thing to realize is that this can't be factored by GCF. First of all, if you looked for a greatest common factor, you wouldn't find one. G doesn't go into everything. There's no number that goes into everything. Your only GCF would be 1. But you'll notice that the format is something x squared plus 7g, so a number times x or g, and then plus 10, and then a constant at the end. So that tells you to go into two binomials that multiplied to produce this answer. So what two binomials multiplied to get this answer? Well, I know that g times g must have given me that g squared. Now, we're looking for two numbers that have a product of 10. They have to multiply to give you 10, and that they have a sum of 7. So you guys could probably think of it really quickly in your head. What two numbers multiply to give you 10 and add to give you 7? 2 and 5. But let's say you don't know, or I give you harder problems where there are more possibilities. What you can do is you can go to the constant and list its factors in order. 1 times 10 is 10. 2 times 5 is 10. Once you've listed its factors, you can kind of look at them and say, okay, which pair have a sum of 7? Well, 2 plus 5 is 7. So that tells me that in my parentheses, I have a 2 and a 5. Now, notice I haven't put a positive or negative sign on them because it can get a little bit complicated. If you look at the number at the sign of the constant, the positive 10, that tells me that the signs are the same. So they're either both positive or they're both negative. If they're the same, I go to the middle term, and the middle term tells me what sign they were. So this problem tells me that they were the same sign, that they were both positive, which makes sense because positive 2 times positive 5 is positive 10, and positive 2 plus positive 5 is positive 7. Okay, try example 2. I'd like you guys to pause the video periodically and then come back. All right, so pause the video right now and try example 2 the same way. All right, for example 2, two binomials, a times a gives me a squared. I need factors of 30. 1 times 30, 2 times 15, and 3 times 10 make 30. I need a pair that adds up to 13. 10 plus 3 is 13. So I put 3 times 10. Any order is fine. And then the sign at the end tells me that the signs are the same. And then I go to the middle. They're both positive. Positive, positive. So a plus 3 times a plus 10. If I were to FOIL that, I would get a squared plus 13a plus 30. Okay, now the examples are going to get slightly different. So example 3 now, I have d squared minus 17d plus 42. I'm going to start out the same way. Two binomials multiplied to make this answer. D times d is d squared. I need factors of 42 that add up to 17. So here I have more possibilities. 1 times 42, 2 times 21, 3 times 14. 5 doesn't go in. 6 times 7 is 42. And I think that's it. I need a pair that adds up to 17. I could look at it, see it's all organized if you go in order. 3 and 14 add up to 17. I put the 3 and the 14, and now I look at the signs. So the sign at the end tells me that the signs are the same. But now look at the middle. The middle is negative. So this tells me that they're both negative. And negative times a negative gives me positive 42. But when you add the two negatives, negative 3 plus negative 14, you have a sum of negative 17. Okay, pause the video and try example 4. Okay, for example 4, I know two binomials, x times x. I need factors of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. You can use your calculator to just go in order. Just divide by 2, divide by 3, divide by 4, divide by 5. If it goes in evenly, write it down. And I need a sum of 15, so 3 and 12 make 15. 3 and 12. Now, go to the sign at the end. That tells me the signs are the same. They're either both positive or they're both negative, but I go to the middle. That minus there tells me that they were both negative, which makes sense, again, because negative 12 times negative 3 is positive 36. But when I add negative 12 plus negative 3, I get a sum of negative 15. Okay, now they're going to get a little bit more complicated. So take a look at example 5. The sign at the end here is no longer positive. It's now negative. This tells me that the signs are different. One's a positive, one's a negative. So if you have one number that's positive and one number that's negative, like let's say you had 8 times negative 5, right? That's negative 40. But when you add a number that's positive with a number that's negative, you're not really adding them. 8 plus negative 5 is 3. You're actually subtracting them. So now, when we look at the pairs of the factors that have a sum of 6, it actually won't be a sum of 6. It'll be a difference of 6. Okay? I'll take you through it. So, example 5, I have two binomials. M times m gives me m squared. Factors of 27 still do the same process. 1 times 27 is 27, and 3 times 9 is 27. But this time I need a difference of 6 because the signs are different. So 9 minus 3 is 6. So I put a 9 and a 3. Any order is fine. And now, if the signs are different, the sign of the middle number is going to be the sign of the bigger number. This tells me that the bigger number is positive. So the 9 takes the positive and the 3 takes the negative. Because of the rules of adding and subtracting integers, when you subtract those two numbers with different signs, you then take the sign of the number with the bigger absolute value, which we just call the bigger number usually. Okay, so look at example 6. If you want to pause, you can, or you can watch this one. I have p times p is p squared. I go to 18, I need factors of 18. 1 times 18, 2 times 9, 3 times 6. Because the sign is negative at the end, this tells me that the signs are different. So I need a difference of 3, because the middle term is 3. 6 minus 3 is 3. So I put a 6 and a 3, any order. But now I go to the middle term. The middle term is negative. This tells me that the bigger number is negative. So this time, the 6 takes the negative and the 3 takes the positive. because when I multiply negative 6 times 3, I get negative 18, but when I add negative 6 plus 3, my sum is negative 3.